post-lunch session, but I'll try to keep it short and interesting, like the previous speakers did. We heard from Professor Rajan about the exciting possibilities of application of geospatial technology for various industries. He actually exhorted us to look at very unconventional areas such as homeland security, agriculture, waste management, recycling, and so on. So I think those are great ideas, and we would like to endeavor to do so from at least Trimble. Mr. Rao talked about all the challenges of running the world's largest mining company, coal mining company, and the application of geospatial technologies for some very innovative, complex problems and innovative solutions. Actually, mining is a little bit piece of my presentation also, because we believe the application of geospatial technology is very crucial. So the topic, geospatial-enabled economy, is very apt. I think we are at the cusp of something very unique. I kind of liken it to what IT did to e-governance and e-economy. 20, 25 years ago, if you went into a government office and talked about laptops and software and IT, they all thought that this will never happen. It'll put a lot of people out of business, out of jobs, and it'll never be taken up. Today, we can't live without our iPads, our laptops, our PCs, software, ERP, CRM, you name it. And it has made the office environment really, really efficient, transparent, and a quick decision-making environment. We go to the field, and it's again all paper, non-real-time information, misinformation, and so on and so forth. So I think geospatial technology is going to do to the outside world what IT did to the office. So I think we are in some very exciting times. And if you look at the data that it gets collected by the various geospatial technologies, that bears proof that we are onto something really big. I mean, if you look at the data collected alone, it's grown exponentially, and it will continue to grow through crowdsourcing, through very high definition, high resolution satellite imagery, LIDAR, high definition orthophotos, et cetera, et cetera. So this is not going to stop. What this has really enabled us to do is go from two-dimensional paper maps to digital imagery in terms of GIS, to now we want to really create virtual 3D world. You talk about Google, you talk about Facebook, you talk about any social media, they all want to create 3D virtual worlds. And so the amount of, and this is just going to continue. We are just at the cusp of something that is going to continue for the next foreseeable future. If you look at any industry that is very pertinent to the nation's economy, whether it is energy or mining or oil and gas, utilities, highways, really there is a common theme around it, which is geospatial information. So we consider geospatial information as very, very critical and really at the base of all industries. And the use of geospatial technology to move information back and forth between the field to the back office and back and forth is going to be the enabler for us to get to the next level of efficiency and the next level of economic growth. We all know that we just started the 12th five-year plan. There is literally $1 trillion allocated for infrastructure development over the next 5 years. And this is going to be in the areas of highways, utilities, water, energy, and so on. And I think geospatial technology is going to play a very key role in utilizing these dollars, these valuable dollars, to maximize the benefit for the citizens of the country and thereby get reflected in the economic growth of the country. We are now at 5.5%. The goal is to grow at 9%. And I think geospatial technology is a very key component. So information moving back and forth is the key. It's a little bit slow. Okay, so if you look at information, it is really coming from a lot of different directions, from enterprise servers, from crowdsourcing, from intelligent machinery in the field, from reports that are generated in the field, and from devices such as handhelds. So it's all coming down from various different angles, and that's what is giving rise to the growth in the amount of information that is that we are experiencing. So we already heard a few areas, and I'm going to just build on what the previous speakers did, and give you an example of how geospatial technology is used in a couple of different industries that are, I think, very near and dear to our nation as it grows into the next 5-year plan. So cadastral mapping is a very important initiative. As we all know, the government has initiated the NLRMP program. It's a nationwide mandated program, but it's a state subject which deals with essentially modernizing land records. So this is an example of what was done in an African country where field data was taken, and then it was brought back to the office, and using software, basically we created a three-dimensional rendition of the map, sorry. Okay, so for some reason it's not going through, but this is a very nice moving picture where you get all the information about the parcel. For some reason it's not showing up. So anyway, we'll skip that. So cadastral mapping is a very important subject for us from our nation's point of view. We all know that India has some of the largest road networks, whether, up to, I think, about 3.3 million kilometers of road network, and we are in the process of adding more highways and state highways and national highways. Geospatial technology can be utilized very effectively to build high-quality road infrastructure quickly, within time, with less rework, and better quality the first time, and with much better tolerances. So here is an example of, if you want to get an alignment of a road from point A to point B, instead of doing it manually and piecewise, you can have expert system software that can literally give you multiple alignments in 3 dimensions, taking into account various considerations, whether it is an environmental consideration such as the presence of an environmentally sensitive area or a religious landmark or a dump site or anything that you can think of. You put that as a constraint, and the software will create automated alignments which you can fine-tune later on based on further considerations. You can not only take that, create that alignment, but you can also map it and create a 3-dimensional model using Google Earth or other map data. Using survey data, you can create very detailed dimensional, actually the design of the road or the highway, and you can load that onto machines, or various types of machines, whether it is an excavator or a bulldozer or a motor grader or a paver, and you can literally take the digital design, put it on the machine, and basically let the machines run and create your road infrastructure based on the design. Not only that, you can actually monitor each and every equipment that is on the field as regarding utilization, maintenance, the health, and so on. And these are all available in real time. I think there is a little bit of a problem running those movies. I think something is not working, but that's fine. So essentially, as I said, geospatial technology can be used at every stage of a road building process. Similarly, for building construction, such as the bird's nest that was created by the Chinese government for the Olympics, it was created using very advanced geospatial technology, using for steel and concrete structures. And you can see the complexity, and this whole thing was essentially created in 3D, verified for any complications and conflicts before it was sent to the factory to be built. So if you look at any sports structure, whether it is a stadium or a racetrack, geospatial technology is utilized. Professor Rajan mentioned about agriculture and the use of water and the wastage of water. I believe that technologies exist today which can enable optimal usage of input parameters, whether it is water, insecticides, pesticides, fertilizers, and so on, and really give the farmer a very optimized input and an optimized output so that his profits are maximized. Whether it is land preparation or planting or harvesting or even post-farm gate, information is readily available. Digitized information is readily available to create what we call as a connected farm. If you look at the picture, essentially the farmer has all the information that he needs from the farm, from his huge farm or small farm or whatever, on the laptop or on the iPad, regarding the yield per square meter, regarding how much water was taken, regarding when he planted it, and so on. So actually there is a very interesting case study that was done whereby a soybean farmer had planted his 500 acres, and then the next day there was huge flood, a lot of rain and huge flood, and then his field was immersed for about 3 days. And then when the water drained, the top of the soil had become very hard. And using geospatial technology, he was able to retrace the path where he planted the soybean, and he was able to loosen the top of the soil, and only those places where the seedlings were planted, and they regrew again, they grew back. Otherwise, imagine, without such a technology, he would have had to redo the entire operation again with a lot of wastage of time, money, and effort. So such technologies for precision agriculture do exist, and of course, we need to adapt it to the Indian conditions. Why? Because normally, many of these are targeted at large farms. As we all know, in India, the farm size is quite small, going from father to son, so on. But then, on the other hand, we have an interesting problem whereby farm hands are hard to get. So mechanization is on the increase. Now the question is, how do we make it affordable? How do we adapt it to the Indian conditions? But technologies do exist for that. Transportation, whether it is rail, roads, whatever, is a very important aspect of a nation's economy, and geospatial technology can play a very important part. I already mentioned about the alignment that can be achieved, optimal alignment that can be achieved through the use of geospatial technology. But not only that, such technology can be used during the construction phase, during the maintenance phase, and so the cycle continues. Here you see some examples of very high density scanning images that were taken to actually augment, to actually extend road, to widen it. A railway line that can have very precise alignment with the help of a Gedo trolley. And the truck, if I can get that picture, so again the video doesn't work. So let me go back. So if you look at that truck, it is actually going on a rail, and it is actually, and if the video had worked, it would have been good, but it actually would spray weed killers, because weeds are a major problem along railway lines. When the weed grows and the roots become very thick, they can actually misalign the railway track. And one way is to obviously spray it en masse across the track. The other way is to use geospatial technology to minimize the use of chemicals such as weed killers. So such a truck can be deployed to essentially optimize use of, as I said, weed killers and ensure the integrity of the track, especially when high-speed links are involved. The Chennai Metro uses some of the geospatial technology to ensure precise alignment. This is a couple of sample pictures that were taken. Transportation, Mr. Rao mentioned about use of GPS-based truck tracking to ensure that pilferage doesn't happen or is minimized. Similarly, we can use GPS-based fleet management and cargo management solutions to achieve 30% improvement in productivity, asset utilization, and also compliance, driver compliance. Similarly, reduction in fuel utilization, carbon dioxide emission, obviously, because of lower fuel, and lower cost of operation. And then really, because of the fact that there is real-time data going back and forth, you are empowering the driver, whether it is a field worker or a transportation and transportation truck driver, you are empowering him to make instant decisions regarding delivery of assets. And also safety. There are cases where a driver either went missing or the vehicle was hijacked and the assets were recovered within a few hours. Without GPS and GIS technology, such a quick recovery would not have been possible. Building construction, another very interesting area where GIS technologies can be utilized for various trades, from the architecting and design of the building to the various different trades, whether it is mechanical, electrical, plumbing, concrete, steel. Geospatial technology can be utilized to again reduce rework, increase the quality, reduce the time to build. In fact, at Trimble, we are actually putting where our money where our mouth is, because we are utilizing all these technologies to build our next campus that is coming up in Colorado. So if you look at construction, it's always a combination of horizontal and vertical construction, whether it is a building or a satellite city being built. And really, if you look at that, it's roads, it's site layouts, it's buildings. So geospatial technology becomes an integral part of these capabilities. And this is an example of how we generate three-dimensional models for various trades, whether it is a general contractor or even an owner of the realty. So for example, if the owner wants to know when his building will be done, what is the cost, what is the inventory, what is the timeline, you create a 5D model, three-dimensional model plus cost and time elements to create a 5D model, and this can be updated regularly through the use of geospatial technology. Mr. Rao talked a lot in detail about mining, so I'm just going to show a few slides where we believe mining is a prime area for application of geospatial technology, all the way from the exploration stage, when you do the basic survey before you even create the mine, to detailed mine design, to construction or operation. During the construction of the mine, there are geospatial technologies available to optimize the use of the space within the mine. And during the production stage itself, as Mr. Rao mentioned about the dump size, the stability, the slope stability, the monitoring of all the vehicles, the construction of the roads that go in and out, and including things like the trucks that take the ore or the coal away from the mines. And during reclamation, GIS technologies or geospatial technologies are a must to be used for environmentally considerate reclamation. So this is an example of a mine design software. It is an artificial intelligence software that takes into account various inputs such as the geological data, such as the economics the economy model for how to optimally extract the ore, and creates a model that can be actually, again, superimposed on a Google map to create three-dimensional models using software such as SketchUp. So here is an example of a bench-based mine, open-cast mine design. And the interesting thing is that this kind of exercise reduces the timeline from months, 3, 4, 5 months, to a few days or a week. So because of that, it allows you to optimize the design of the mine periodically, every quarter, and thereby extract more ore. This has been proven in the case of gold mines in South Africa, and certainly we are looking at other possibilities such as coal and iron and so on. So this is just one example of use of geospatial, and you can create the superimposition. The other thing, of course, is mine safety, subsidence, so that we can create permanent GNSS infrastructure and use geospatial technologies to monitor mine subsidence and the integrity of the mine, and then reclamation. So, couple of more slides only. Connectivity is key. You have all these data that is residing in the field, you have all these data that is residing in the back office. How do you connect the two to derive meaningful real-time information? And that's where the whole concept of connectedness comes in, and thanks to advances in wireless technology, whether it is 2G, 3G, 4G, Wi-Fi, WiMAX, Bluetooth, whatever, we are able to move more and more data between the field and the office and back and forth to create efficient operation in the field. And so connectivity enables professional, government, and the consumer to derive the maximum benefit out of geospatial technology. So in closing, we are moving from 2D to 3D. Everything is going to be a virtual 3D world, and with great accuracy. Professor Rajan talked about 70 centimeter accuracy. Now, 70 meter accuracy. Now we are talking a few centimeters and even a millimeter accuracy. There are technologies available that can turn on and off individual nozzles on a spraying machine in an agriculture field, depending upon how the contour of the field is. So we are talking very accurate spatial accuracy in 3D. So the volume of data is obviously very huge. Clearly, technology and economic incentives aligned with government policies are needed for geospatial technology. I don't want to go into a lot of details, but really, the whole thinking has to mesh with the growth of technology. So the National GIS is a very positive initiative in this regard. So I think best things happen when all three are aligned. And let me tell you, we are in exciting times. My background before this was, as I said, high-speed telecommunication. But having been with my current company, Trimble, for the past 5 years, I've never been more excited about the future of geospatial technology. And I think we are in for a great ride. And with that, I'd like to thank you for your time and appreciate the patience. Thank you.